What's up everyone, you are watching episode 3 of my multi-part series on building a clean architecture model view presenter Kotlin Android app. So in this video we're going to be talking about the domain layer. Now I'm not going to go into super fine detail into this clean architecture stuff because it can get fairly complicated, but suffice it to say that we will be writing a use case, or interactor as it's sometimes referred to, and the purpose of this object is kind of twofold. Number one, part of the purpose of these things is to basically hide details between the front end and the back end. Now, when I say hide, I basically mean the front end really shouldn't know intimate details about the back end, and vice versa. As we write the code, that should start to make a little bit more sense if it's vague now. And the other thing that writing these use cases will do for us is it'll kind of help us represent our problem domain in a fairly abstract way. And if you're not familiar with the problem domain, we'll be talking about that in a second. But basically, just to reiterate, there's two things we really need to do with this domain layer. Number one, figure out what kind of data we need to represent and what we need to do with that data, essentially. And then the other thing that this little layer will do for us is it'll help us to keep our front end basically fairly agnostic from our back end. And as we'll see later on, that's actually quite important. So without further rambling, let's get to some slides. So one of the reasons why I chose a calculator of all things for this tutorial is that a calculator has an incredibly simple problem domain and problem statement. So let's begin with talking about what problem domains and problem statements are. So for the problem domain, essentially how I think of it is a high-level description of the data which our application needs to represent, as well as some kind of a high-level description of what our application needs to do with that data. So within a calculator app, as I said, it's very simple. We need to evaluate, so already we have the thing our application needs to do, a valid mathematical expression. Okay, right off the bat, there we have the data which we need to represent, and I've just added a little thing into the problem statement, which is that it needs to be in string format. And the reason why I wanted to do that is I wanted the front end to just be able to pass a string into the back end instead of having to worry about decomposing the expression into postfix notation, etc., etc. So that's the basic idea there. So just to really reiterate this point here, the problem domain for any given application is the data which you need to represent and the things you need to do with that data. And this is generally a very good place to start when you're designing a new application. So as I mentioned before, a lot of what we're going to be doing today is writing a use case, or interactor as it's sometimes called. Now I do want to stress the fact that it's not actually very important what you call these things. The most important thing is just that you understand what they're doing for you. So just to begin with, how this is basically going to work is some click event, so say the evaluate button, is going to be clicked in the view. That is going to be propagated to the presenter as an event. The presenter is going to grab whatever the view's display is currently, the calculator's display, and then pass that as a string into a use case, and the use case is going to be called EvaluateExpression. So essentially why we've done that is we want to set up a situation where the presenter, which you can think of as like the front-end thinking part of the application, the front-end decision maker, only has to worry about coordinating, say, events from the view model or the fragment. It doesn't have to worry about more back-end type stuff like coordinating the validator and the calculator, decomposing an expression, etc., etc. So essentially we have kind of like a decision maker in the front end and a decision maker in the back end. Now use cases and interactors are kind of technically a middle layer, but since this application is so simple, I'm basically boiling it down to just a front end decision maker here, front end decision maker down here, and then the validator will do whatever it needs to do. It's like a service class. We'll propagate that event back to the use case. Then the use case, if appropriate, will ask the calculator to do its calculation. And when all of that is said and done, the resulting calculation, if successful or if it fails, will be propagated back to the presenter, and then that's where the presenter will decide what to do appropriately with the front end. So that's basically what we're going to be working on today. Okay, so the first class we're going to be writing for today is going to be called Expression. Now, just one important little note here. Normally I would actually write the use cases and the domain models before I got to the data layer, but just for the sake of the flow of this tutorial, we're going to kind of bounce around a little bit, but just a little hint there. So what exactly is the domain model? Like I said, it's supposed to be like a high-level description of the data that we need to represent, which is in this case just a string expression. So go ahead and right-click on the domain model package, go to New, Kotlin file, and this file will be called Expression. We're going to say class expression, and we're going to say private constructor. I'll talk about that in a minute. And then this is going to have two different properties, val result string, like so, and then also val successful. And we're going to call this a Boolean. Oops, Boolean, there we go. And that is basically all we need to do there. Now, notice how I've got this thing called a private constructor. So what does this mean? I'm basically saying, and this is like a Kotlin thing here, I'm basically saying I don't want the constructor to be directly called. Now, why would I do something like that? Obviously, I need to have some way of instantiating this particular object. Well, I'm going to use kind of a special way to instantiate the object, which I could be wrong here. I believe this is called the static factory pattern. If nothing else, it's basically a way to build objects fairly statically. So I think if that's not the correct name for it, hopefully you'll forgive me for the confusion. Anyways, what we're going to do, and this is one of the things I wanted to teach about Kotlin in this particular video, is we're going to set up a companion object. Now, a companion object is going to function very similar to, say, a static class method in Java. So what I'll do is let's write it out, and then I'll talk about it a little bit more. Now, in this case, I'm just going to copy and paste the code in here, and we'll talk about it. So, number one, we have two methods for this little companion object block here. So essentially, any of the methods exposed within this companion object, and you can only have one companion object per class. Essentially, these methods are going to be exposed in a way very similar to, like, as I said, a static class in Java. So you're going to be able to call expression.create success model or expression.create failure model. So essentially what I'm doing is I'm hiding the actual constructor behind these companion object methods. And why I want to do that is it's basically going to do two things. It's going to sort of increase the immutability of this object, and it's also going to just basically make it easier to work with. So instead of creating expression and then passing in the string and a Boolean, I basically just say expression.create success model if it's successful, and then it will automatically say successful down here. Or if it's a failure model, so if some part of the execution or validation or calculation fails, then we just pass in sort of like an error message result, and then we say successful false. So essentially, it's really just a way to, like I say, create a little bit of extra immutability, to have more fine-grained control over how we create this object. And yeah, it's also, as we'll see later in the code, very, very legible. So that's basically it for expression. And yeah, so just case in point with Kotlin, if you want to do something like a static class method, then you can use this companion object code block here. Okay, so before we can finish off our use case itself, we're just going to need to add in a base scheduler provider class. So I won't go into fine detail here, but in the main package, we're going to right click and go to New Package, and we're going to call this package util. And then within the util package, we will create another package called scheduler. Within scheduler, we're going to create a file, which will be an interface. And this interface is going to be called base scheduler provider. And let's just write it out really quickly, and then I'll talk about what it does. So interface, base scheduler provider, and it's just going to have two methods. One of them is going to be fun get computation scheduler, which is going to return just a scheduler. Let me make sure I have the correct one here. Yep. And we do want this to be sort of a parent class scheduler, not like a what am I trying to say here? A class which derives from scheduler. We do want it to be at a higher level of abstraction. Then we're going to create, let's just hit Control D, that's a little quicker. And this one's going to be get UI scheduler, and it's also going to return a scheduler. So why am I talking about scheduler? So when you're working with RxJava, one of the things you're able to do is you can tell it to basically execute and listen for different events on particular schedulers. So if you're not familiar with threading, you're going to want to look into that a little bit. But basically what we're going to want to do is when we invoke this method or this method, we're basically telling RxJava how we want it, which thread we want our RxJava implementation to execute on or listen to. Now, in this particular case, you might be wondering, why did I make this an interface? Well, we will make a class which inherits this interface, but the reason why I've kept it as an interface is so that it's super easy to mock in tests. So whenever you're executing your RxJava tests or your classes which use RxJava threads on the JVM, I'll just make a note here, make sure you execute Rx calls on the schedulers.trampoline scheduler, which is different from, say, the schedulers.ui or schedulers.computation. I'll talk about this more when we actually get to unit testing, but I'll just include this little note here. Whenever you're using your RxJava stuff on the JVM, you want to be using the trampoline scheduler, which basically operates synchronously, I believe is the correct term. So yeah, that's basically all we need to do for that one. Okay, so now that we have that sorted out, we can finally get to writing out our use case itself. So we're going to go back to the domain layer, and of course within the use case package, right-click, new Kotlin file, and this one's going to be called EvaluateExpression. So whenever I'm giving a name to a use case, I'm trying to think of like generally a two-word statement, so usually a verb followed by the noun, which is the data that will be acted upon. So in this particular case, we have EvaluateExpression. But a lot of use cases, I'll call them something like delete alarm, save note, those kinds of things. And the reason why I named them as such is I want things that people can read in this application that are very unambiguous and explicit and not full of a bunch of stupid jargon. So that's one of the benefits of having this domain layer, is you can kind of capture a lot of information in a very unambiguous way because it's kept at sort of an abstract level of detail. Anyways, rambling, let's get started here. Class, EvaluateExpression. And we're going to say private val calculator, calculator, and we're going to pass in, of course, the interface, not the concrete calculator, private val validator. I'll let it do a bit of autocomplete there. iValidator, like so. And then we also need to pass in our scheduler, so scheduler, and that's going to be base scheduler provider, like so. So those are the things that we need for our use case to work, and let's go ahead and start coding the body. But before we do that, I'm just going to add a colon because we want to inherit from our base use case. So that's going to be base use case. Now remember, as I mentioned before, we had that T within the actual interface-based use case. So here is where we will actually specify what we want to be passing around this particular class that inherits from base use case, which will be an expression object. Perfect. So it's going to pop up and say that we haven't implemented the method that we're inheriting from the parent class, or the interface. So I'm going to click on this red spot here, hit Alt-Enter, implement members. And then we'll go ahead and start implementing this code here. Now, some of this is going to be some RxJava stuff which isn't super familiar to a lot of people. So what I'm going to suggest is I've made a roughly half-hour long video discussing what RxJava is, the observer pattern, and kind of the fundamentals you need to know about what I'm going to be going over. So I will give you a little bit of detail and explanation here, but I highly, highly suggest you go and watch that video because RxJava is just not really something you can stumble into and understand unless you have a background in, say, functional programming. So I'll link in the description box below for that video, but let's get started here. So first things first, so we receive an expression as a string whenever we call this method. So the first thing I want to do is I want to validate that string before I even bother trying to calculate it. So what we're going to do is we're going to wrap most of this stuff in an if statement, which will be validator dot validate expression, and we'll pass an expression. So basically what we're saying is if this expression is valid, then go ahead and carry on with this stuff. Now you might be wondering, why didn't I represent the validator as part of like an observable stream, but I did represent the calculator as part of an observable stream? Well, the truth is I probably didn't even really need to represent the calculator in RxJava, but in many cases these are the kinds of things that you will want to represent as a stream because they're asynchronous in nature. Now the calculator, again, it probably could just execute synchronously and it wouldn't cause many problems, but on the off chance that this thing is run on a very slow phone or something like that, we're still going to be able to protect our application from the asynchronous nature. The validator is super easy. Everything in there executes synchronously, and so that's why I kept this particular service synchronous. So there's a really key point here, and this is something which you'll hear Dan Liu and a couple other people who are RxJava wizards talk about, which is not every part of your app needs to be represented as a data stream. In fact, if it executes fine synchronously, it's probably, I'll say it is not necessary at all to represent as a stream. So here's the thing about this. I know I'm saying a fairly political statement here, but basically what I'm saying is the thing about RxJava, you don't need to use it everywhere, and unless your entire team is on board with using it everywhere, you probably don't want to. So anyways, let's just carry on here. So first thing we do is we validate the expression. The next thing we're going to do is we're going to say return, and this is where the RxJava stuff starts. We're going to say return calculator dot evaluate expression, and then we're going to pass the expression in right there. So what does calculator actually return? So it's going to return something called a flowable data model, and we're going to need to actually sort of convert from this flowable data model, which is like a data, it's a data model, back into our expression. And the way that we're going to do that is we're going to use flat map. Now, like I say, go and watch that video if you're a little bit confused about what that is. But with flat map, essentially what we're doing is we're saying our calculator is going to emit an object of a certain type. We want to take that type, basically transform it into another type, and then re-emit that value. So let me write the code out, and then hopefully it'll make a little bit more sense. But I understand this stuff is pretty difficult. So just to begin with, we're going to chain a method. flat map. And what we're going to do, and I know this is going to freak a lot of people out, but we're going to type result arrow, which is like similar to a lambda expression, and then we're going to say flowable dot just expression. Yeah, expression. Oops, I imported the wrong expression there. Expression dot create. Sorry, one sec. Totally imported the wrong expression. There we go. Expression dot. Where is it? There we go. Just make sure we have our imports correct there. Create. So this will be a success model, correct? Yes. So in this case, this is when it's successful. We're going to say flowable. Expression. Let me just reformat this a little bit. I'm going full OCD here, I realize. Create success model. And then we're going to type result.value. Now, one of the first things, and this is something I ran into when I was dealing with RxJava and lambdas, is my first question is, where the hell did result come from? What is result? Well, basically, it's kind of like a syntactic sugar thing. This result, so basically I'm declaring the name of the object here, which will be emitted by this particular method, and the type of this object, which is the data model class, comes from what our calculator emits. So in a word, I'm going to go open up the calculator interface. So, and as you can see here, hopefully it's somewhat visible, this is where that value comes from. This is the type of that value, expression data model, and it's sort of automatically assumed or inferred by the IDE based on what this method returns. So hopefully that's pretty clear. And then we're just giving it a name here. So what we're going to do is we say get this value out of the event stream, and then we're going to say do something with it after this arrow here. And what we're going to do with it is we're going to say flowable.just expression.create success model. Why did I say flowable.just blah 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 create success model? We're saying flowable.just, which is the way you create a flowable or an observable, and we want to create one of type expression to satisfy this return type here. So all of this stuff is going to happen, and it's going to send the expression to this calculator. The calculator is going to emit whatever it figures out as an expression data model or result, and then we're saying let's take the value of that result and map it to a model which is what we actually want to return to the presenter. So all of that essentially is so that we're not returning our model in the data layer to our presenter, which is in the front end or the presentation layer, because we don't want intimate details of the back end going to the front end. I know that's a lot of talking, and hopefully that kind of makes sense, but let's just finish this off here. So the next thing we're going to do is we're going to add just one more chained method call here. We're going to say subscribe on, and then we're going to type, and that's probably not super visible, so this is going to be scheduler, which is our base scheduler provider, and we're going to say get computation scheduler. So that's that there. So this is all we need to write if our expression passes the validation logic. Okay, so before we can finish off our use case, we just need to add a little specialized exception for when the expression does not pass the validation logic. So go ahead and open up the project view and go to right-click on util, new package. This package is going to be called error, and within error we're going to create a file called validation exception. And so what we'll do is we'll say class validation exception extends exception, like so. And then all we're going to type within it is we'll make a companion object, and we're going to say const val message equals invalid EvaluateExpression, and that's really all we need to type here. So basically what I'm doing is I'm saying, okay, I've identified a particular type of exception which is going to happen quite a bit in my application. So rather than just throwing some generic exception, I'm actually going to make a specialized class for it that has a specialized method. So obviously this is a small application and we kind of only need the one class arguably. So you can imagine you could create a couple different kinds of specialized error messages or exceptions in a larger application, and that's kind of a cleaner and more legible way of handling errors. Anyways, let's jump back to the use case here. So to finish this off, I'm just going to get some space here, and we're going to type return flowable. Where are we at here? .just. Then we're going to say expression dot create failure model, and then within that we're going to say validation exception dot message. And so there's two different choices for validation exception. I know this probably isn't visible for you with my screen blocking it. Make sure you pick the validation exception class that we created, not the javax.xml.bind.validation exception. So what I'm trying to say here is make sure up here for the validation exception class it says util.error, not a bunch of other crap that we didn't write, otherwise you'll get an error. And let me just hit enter a bunch of times so you can actually see what I'm doing here. So yeah, and this is how we finish off the error case for our use case. So if it doesn't pass the validation, we head down here and we say, hey, we just create the flowable and return an expression, but a failure model version of it. And as you can see here, this is a little bit more legible and gives us a little bit finer control over creating these objects than, say, just saying new expression, blah, blah, blah. In this case, we say expression.create success model, expression.create failure model. If you're doing something more complicated with like loading screens, you could even add something like an expression.create loading model. So there's a couple different things you can do, and I just kind of wanted to give you a brief glimpse of the static factory methods. So that's basically everything we need to write for our use case here. Alright, so to briefly summarize what we went over, I talked about creating a domain layer, use cases, and domain models as a way to represent our application in kind of a high level and abstract way. And the benefit of doing that is that we can have our presentation layer sort of talk to the domain layer, and that's going to hide the details of the data layer from the presentation layer, and vice versa. So hopefully that kind of makes sense. And one of the most important things I want to mention about this stuff is that, like I say, in a small little application like this, it maybe doesn't make a huge amount of sense, but as your application grows in size, you're going to start to see that keeping this separation of concerns is very, very important. Hopefully you enjoyed the video. If you did, please do consider hitting the like button down below, subscribing, following me on social media, and if you would like to, send me a couple bucks on PayPal or Patreon. Links in the description box below. Thank you for watching, and I will see you next time.